When you hear the word hacking, your mind probably jumps straight to the movies, right? Frantic typing, green text scrolling down a screen, and a whole system breached in like 10 seconds. But what if I told you that real professional hacking is less about chaos and more like a meticulous investigation? Okay, let's dive into the world of ethical hacking, or what the pros call a penetration test.
And that's really the key right there. This isn't just some technical checklist you run through. It's a craft. It's a disciplined skill that mixes deep technical know-how with some seriously creative problem solving. And the whole point? To find security weaknesses before the bad guys do.
So, to really get a grip on this whole process, we're going to frame it as a detective story. We're going to follow our digital detective, that's our pen tester, as they take on a brand new case, cracking the code on a client's entire digital world.
Now, our investigation unfolds in 5 distinct phases. First, our detective has to map out the digital terrain. Then, they start looking for the cracks. After that, it's all about getting proof that those cracks are real. Next, they explore what happens after a breach. And finally, they deliver the most important piece of all, the actionable report.
So every good case starts with our detective arriving on the scene, right? This first phase is all about getting the lay of the land. You gotta understand the environment before you can make a single move.
The pros have a name for this. It's called reconnaissance and asset discovery. Just think of it like creating a super detailed blueprint of a building. Our detective needs to know about every single door, every window, every server, and every device that's plugged into the network. It's about taking a complete inventory of the digital crime scene. And to draw this map, our detective uses some pretty specific tools. Nmap is kind of like their sonar, pinging the network to see what's out there. And Shodan, that's their eye in the sky, revealing what's visible to the entire world on the internet. This initial intelligence is the foundation for the entire case.
Okay, so with that complete map in hand, our detective moves on to the next phase, actively looking for potential entry points. The cracks in the foundation.
This stage is all about vulnerability identification, and the keyword here is potential. Our detective isn't actually trying to break in yet. They're just methodically scanning everything on their map, checking it against a huge database of known security flaws, and making a big list of every possible unlocked door or window they can find.
Now this is super important to understand. Not all cracks are created equal. A potential vulnerability is, well, a theoretical weakness. But an actively exploited vulnerability, whoa, that's a weakness that real-world attackers are already using out there in the wild. Our detective has to know the difference to figure out the biggest risks.
Finding these cracks requires some powerful scanners. Tools like Nessus and OpenVOS automate the search, checking for thousands of potential issues and generating a list of solid leads for our detective to go and investigate.
All right, the detective has their list of potential weaknesses. Now for the really exciting part. It's time to find out if these theoretical cracks are actual, real-deal, exploitable security holes.
This is exactly what they mean by the proof in the pudding. It's where theory crashes right into reality. All that scanning and mapping leads to this one moment, providing undeniable proof that a vulnerability actually exists.
This phase is called exploitation. But remember, we're talking about a digital detective, not a criminal. The goal here is to safely exploit the weakness. It's like carefully picking a lock just to prove that it can be done, snapping a photo as evidence, and then locking it right back up. No harm, no foul, but the point is definitely made.
And to provide this hard evidence, you need a serious toolkit. Metasploit is basically the industry-standard lockpicking set for networks. And then you have specialist tools like SQL Map that are designed to test for very specific types of vulnerabilities.
So, our detective has proven they can get through the door. But for a real attacker, that's just the beginning, isn't it? The investigation now has to answer the big question. What happens next?
This is what's known as the post-exploitation phase. Once our detective is inside, they start simulating what an attacker would do. They move from room to room, digitally speaking, to see what else they can get their hands on. Can they get to the server with all the customer data? Can they find the keys to the kingdom in the administrator's office? This is what tells you the real potential damage of a breach.
Now, to do this effectively, the detective uses some seriously advanced simulation tools. Platforms like Cobalt Strike and Bloodhound help them map out attack paths inside the network, showing exactly how a real intruder could pivot from one small entry point all the way to the company's crown jewels.
Now, sometimes the detective gets called in for a very specific type of case.
investigating a company's public-facing web applications. We're talking about login portals, websites, APIs, all the digital front doors. And trust me, they need their own dedicated security check.
And for this special assignment, our detective pulls out another set of specialized tools. Things like Burp Suite and OWASP Zap are designed specifically to probe web applications for common weaknesses, making sure the public entrance is just as secure as the back door.
Okay, so our detective has mapped the terrain, found the cracks, proven they're real, and even explored what could happen next. After all of that intense investigation, what's the final result for the client who hired them in the first place?
It all comes down to this, the final phase. This is where all the findings, all the evidence, and all the analysis get compiled into one single, comprehensive case file, the actionable report.
And here is the most crucial point. This report isn't for other detectives, it's for the client. The nitty-gritty technical details don't matter nearly as much as a clear, actionable plan. The whole goal is to translate these complex findings into simple risk tables and graphs that basically say, here's the problem, here's how bad it is, and here is exactly how you fix it.
And believe it or not, even this final step has its own tools. Platforms like Dratus and Faraday are designed to help pentesters organize all their findings, collaborate with their team, and generate those clear, professional reports that turn an investigation into a security roadmap for the client.
And that brings our investigation to a close. It really shows that penetration testing is this methodical craft designed to find weaknesses before they can be exploited by someone with bad intentions. Which really leaves us all with one final, crucial question to think about. Your digital doors are being checked constantly by someone. Who do you want to find the unlocked ones first? A digital detective or a digital criminal?